on, in this video, I want to help you to understand how can you use the graph to identify the physical region. So why physical region is important? Because understanding physical region and you are able to see at what point you are not only able to achieve the highest profit, but also not run out, not meeting the constraint requirement. Okay, in order to identify the physical region, it is very important to identify your choice variable and the constraints. So therefore, in the previous 3 questions, we already first identify my choice variables, and the second, we already identify all the constraints we needed for this case. So therefore, we need to learn how can we piece all this information together to identify our physical region. Okay, so when you're try to using the diagram to solve the physical region, and usually it's a little bit limited because in that situation you only can have maximum 2 choice variables. So therefore, this case will be suitable to use our graph to solving it. Okay, so as you notice on the right hand side, I show you a diagram because I already initially creating a few constraints. And on the graph that you are supposed to find the physical region. Okay, so after you identify your choice variable, and then you will use one of the choice variable to label your horizontal axis, the other variable to label your vertical axis. So it does not matter which one you use to label vertical and horizontal axis, but you need to make sure one is for horizontal, the other one will be for vertical. So I decided to use the winter jacket to label my horizontal axis, and then the number of the jacket parkers to label the vertical axis. Okay, so after you label your axis, so you're done with your choice variable. Now let's just focus on my constraint, because you are in order to identify your physical region, you just need to identify your constraint lines and on your diagram, and then to identify the common area, so that will become your physical region. Okay, so I want to use the simplest constraint among the 7 as example first, and then we talk about a little bit more complicated one. Okay, so first, let's starting from our non-negativity constraint. So for the non-negativity constraint, it's basically talking about we cannot produce negative amount of the parker and negative amount of the winter jackets. So we have to have this constraint. So in order to identify the constraint on your diagram, and like I said, it always starting from a straight line, because the straight line is the maximum you can get or minimum you can get. Okay, so in this case, j larger than or equal to 0, that means the minimum value, j has to equal to a value. So j equal to 0 and the p equal to 0. That's are the 2 lines we need to find from my diagram. So those are going to represent my non-negativity constraint. Okay, again, when you try to find the physical region, always first starting with assuming the constraint equal, only have equal sign, because there is no inequality sign, only have equal sign. So for j equal to 0, okay, so for j equal to 0, if you look at it, since I'm using horizontal axis to label jacket, so when j equal to 0, it is talking about this line. Okay, so this line is j equal to 0, because everything on this line is 0 when j equal to 0. Now we move on to the other line, which is here. So this is representing when p equal to 0, because vertical axis is the value for number of the parker. So every value on this horizontal line is when p equal to 0. So now I finished identifying my non-negativity constraint. So before I move on the other 2 about demand limit parker, I want to help you to understand that how can we actually reflecting j larger and equal to 0, because we only identify j equal to 0 and p equal to 0, but the reality for the constraint is j larger and equal to 0, p larger and equal to 0, right? So what you are looking for is looking for the area. So for instance, for j larger and equal to 0, so that is the area when j larger and equal to 0, so which is this whole area, right? Okay, and then similarly for p larger and equal to 0, has to be this area. So why is that? Because if it's not, this area p will be, if you go opposite direction, which is this direction, so the p will become smaller than 0, right? So therefore, I using this shaded area to identify what is j larger and equal to 0 means, what is p larger and equal to 0 can be represented on this diagram. Okay, so now we finished non-negativity constraint. Let's move on to we call this as demand limit constraint, because in this case, for this constraint is become very important. The business does not want to produce more than what they can sold, right? So therefore, they want to make sure the jacket is not produced more than 400 and the Parker is not producing more than 150. So similar idea, in order to find these two constraints on the diagram, first of all, we need to assume J equal to 400 and then find this line. And then for the other one is P equal to 150 and then find this line. And then based on the inequality sign to find the area that representing the inequality area. Okay, so first, let's find the J equal to 400. So when J equal to 400, we just need to find based on so the J, we use a jacket to label horizontal axis. So the 400 line, okay, let me change into the red color. Okay, the 400 is that here. Okay, so that here is when J equal to 400. And then if we draw a vertical line, so this line means everything on this vertical line is J equal to 400, right? So anything on this line is J equal to 400. And then similarly, for P, we need to find a P equal to 150. So P equal to 150 is here. So this horizontal line is representing P equal to 150. So that means everything on this line, P equal to 150. Okay, so after we identify the boundary of the constraint, now let's look at the corresponding area to this constraint. So first, J has to be smaller and equal to 400. So that area will be representing at here, right? And then for P smaller than 150, I will changing the color, okay? I will explain the reason why changing color later. So P also need to smaller has to be smaller than 150. So anything above the P equal to 150 is larger than 150. Anything below 150 is smaller than 150. So therefore, this whole area representing P smaller and equal to 150. Okay, so those are the easy one because they are straight line. Let's move on to a relatively difficult problem, right? So we have 3 more constraints. Let me focus on this constraint is for the machine time. As you see on the diagram, I already helped you to identify this line, right? Machine time constraint. I want to explaining how did I found this constraint. So all the constraints we work on here are just straight lines. So as you learn the geometry, in order to find a straight line, you just need to find the 2 dots on the line. And then once you're connecting the 2 dots, you are able to identify that straight line, right? So we are using the same idea. So first, we need to, first of all, focusing on the constraint when we only have equal sign, right? So that will be 1.5 J plus 2P equal to 650, right? 650. So what I usually do is just assume one of the variable equal to 0. And then since one of the variable is 0, I plug in the 0 and then to in this equation and to solve the other variable. So let me give you more detailed answer here. So I'm changing to blue. Okay, let's see. Let's assume my P equal to 0. So let's say P equal to 0, right? If P equal to 0, this equation will become 1.5 J equal to 650, right? So then J will equal to 650 divided by 1.5. So this is going to give me the value of 650 divided by 1.5. So we will receive 433. So it's approximately 433. So therefore, that telling me that when the dots j equal to 433 and the p equal to 0, that will be the first dot I can identify will be on this line. Okay, so therefore I go to my diagram to find where is j equal to 400 and p equal to 0. Okay, so first of all, horizontal axis is used to label for jacket. So therefore, I'm looking for the value 433. So since I already created the dots, you might not be able to, so it's 50 increment. So actually here is not 450. It is close to 450 because the edge is here is 450. So this line, this dots here is when j equal to 433. So how about p equal to 0? So p equal to 0, which is in the allocate this horizontal line, right? So therefore, the intersection here, what you see is one of my point A, one of the A point where j equal to 433 and the p equal to 0. Okay, now I got my one dots on the line. I need one more dots, and then once I connecting these two dots, I will be able to get in this machine time constraint, right? So I will use the same idea. Let me zoom out a little bit. Okay, let me zoom out a little bit. Okay, so I will use the same idea, but this time I'm assuming j equal to 0 instead of p, right? J equal to 0, and then this equation will become 0 plus 2p equal to 650. Then I solve for p, and the p will give me 650 divided by 2, and I will receive 225, okay? So therefore, the second dot I'm looking for from the diagram is when j equal to 0 and the p equal to 325, okay? So when j equal to 0, that's here, right? And then, but at the same time, p has to equal to 225. So actually, if I try to extending my line here, so the dots here, my B point, it is when j equal to 0 and the p equal to 325. And then once I did that, I connecting these two dots. So I'm able to get in my machine time constraint, okay, machine time constraint. Again, this is the boundary of your constraint, but it's not the constraint itself, since the constraint has smaller and equal to, so it's representing to an area, okay? So when you see the diagram, that is not the vertical horizontal axis, but it's a line, right? So it's a downward line or upward line, doesn't matter. So if every time you see it's a smaller and equal to, it's always representing the left-hand side area of this line. If it is larger and equal to that value, that will be the right-hand side of the area, okay? Since we've seen here, the constraint is a smaller and equal to, so we are looking for the right-hand side area. Okay, now you will ask, Dr. J, why we need to identify those areas, okay? Later on, I will show you the final answer after we identify the fabric constraint and also the labor constraint. So the reason we try to identify I use different color for those areas is because in order to find physical area, you are looking at the overlapping areas, okay? So if since as you see, every constraint is representing by an area, we are looking for the joint area, okay? Let's see, for this problem, if we only have this 4 constraint plus the machine time constraint, so where's my physical area? So the physical area will become, let me changing the color. Okay, my physical area. So my physical area will become the common area we identified so far. So that will be this area. Because if you look at my shaded area, only this area have all color of the area. I use different color, right? So this is going to be my visible area. it is very important that you're not only able to identify the boundary of your constraint, but also you need to know which direction of the area actually representing the constraint. Okay, so then after that, the common area for all the constraint, that become my physical area, okay, physical area. Okay, so like I said, we still have 2 more constraints, so let me show you the final answer, okay. So we will walk on the same, using the same method to identify the constraint for the fabric, and the constraint for the last one is the labors. Okay, let me pull this result. And then we're going to focusing on the physical area, okay. So when we only have the machine constraint, demand constraint on the Parker, and the demand constraint on the jacket, and then the non-negativity constraint, which is this area, right? Remember? So our area is a little bit wider than actual we have here, because after we add in the labor constraint and the fabric constraint, as you notice that the actual physical area become this area. Okay. So this become my common area. So this is the physical area. Okay, physical area. So like I said, in order to identify the physical area, first you need to know to find the boundary of your constraint by assuming you only have equal sign, identify those lines. And after you identify those lines, you need to base on inequality sign, right? To identify is the areas on the right-hand side or left-hand side. And after you identify the area represented by each one of the constraint, and to find the common area, so that will become your physical area, okay, physical area. Okay, so for the requirement for this class, we only want you guys to know where's the physical area, but since this lecture will give you more information about physical area, I want to talk about why this physical area is very important. Because after we know the physical area, the next task will be identify your objective function, and then the objective function will always happening at those corner points. Okay, those corner points. As you see the corner point here, right? You see a bunch of corner points. So those corner points is where we are able to find the combination of my choice variables that are able to maximize the profits. So in order to find which corner point can give me the max highest profit, we just need to plug in the value of those corner points and to see which one give you the highest profit. Okay. However, we're going to leveraging using Excel to help us to find the best combination of your choice variable, and also at what point you maximize your profit or minimize the cost. So we're going to focus on using Excel solver to actually find the answer, but it's kind of important for you to understand how to find the physical area using the graph. Okay, so in next video, we're going to look at this case one more time, but in that video, we're going to learn how can we set up Excel, and then so that we can use Excel to help us to solve this optimization problem.